What's up, everyone? I'm coming to you today with a workshop video, and I wanted to talk about a question that I get asked really frequently, and that question is, how hot do I make the Kydex? And until now, I had really just kind of had a, you know it's done when it's done. You can sort of evaluate the surface texture and the pliability and the appearance of it, and then you proceed from there. And you sort of, eyeball it based on your oven temperature on your dial. The other day, I went out and I finally invested in a little non-contact thermometer, which is going a long way towards helping me determine, the temperature of the Kydex with a greater level of precision. And using this device combined with the Kydex technical briefs, I am getting deeper into what this material is capable of. Now, I want to share something with you that's in progress. Now, using the following technique and information, I'm able to. This is a model for the M&P 45 here, and as you can see, this is 0.08 thickness. Right. Well, I'm not using the 0.06 for this holster. However, I'm achieving a level of detail and definition. I mean, in these, you can even see the slide serrations through the 0.08 thickness. So we're getting pretty detailed with this definition here, using not an industrial process, not any kind of high-tech process, not a vacuum form, or any kind of sophisticated heating or oven. We're doing this in the home with a non-industrial process. And this is the kind of definition that's available to you. This isn't even like professional level equipment. This is at-home DIY stuff that you can do with a toaster oven and a thermometer and a little bit of knowledge. Now we're gonna go over this. I've got a piece of Kydex in here right now, but as you can see, I've got the dial down all the way, and that's going to get. I'm going to come back and talk a little bit about that as I talk about the heating. I went over a video earlier about heating it up slowly and making sure that everything's nice and warm when you do your press, and I want to expand on that in more detail now that I have more testing equipment and better specifications for what we're talking about here. So we're going to come over here to the computer and we're going to look at its Kydex Technical Brief TB116 thermoforming Kydex thermoplastic sheet. And they go on and they have a little introduction and whatnot. And then we get into a section called Forming Guidelines, right? The sheet should not exceed 400 degrees Fahrenheit. We're going to do this in Fahrenheit because it's what I'm familiar with, right? So for thicknesses from 0.06 to 125, we're looking at a working temperature of about 360 to 385 degrees Fahrenheit. And some of this depends on oven conditions, right? And obviously they mention here cycle times will vary depending on oven conditions and grade of Kydex sheet being formed. When forming the Kydex sheet, it's better to rely on sheet appearance during heating rather than on fixed cycle times, which means you don't just say, oh, it's going to be 300 degrees for a minute and a half and you should be good to go. There's going to be a certain amount of, you got to get a feel for it still to a degree, because of, for instance, we'll go over here and look at the sheet, the technical brief TB117, troubleshooting thermoforming problems. Now, I know that I have experienced poor detail in the formed part, right? Obviously, sheet too cold. The sheet is scorched, right? Surface too hot. Blushing or discoloration, right? That's or like glossing, for instance, right? If part of your sheet is shiny and another part isn't, that's overheating. Wrinkling, etc. Surface imperfections, shiny spots, distortion, uneven cooling. Like, these are problems that I have come to experience. And they give you a guideline for the thickness and the heating time. And I think that is based on industrial, professional grade material heaters. However, we do not have that, so I've had to develop some guidelines for myself in terms of heating. So instead of just slamming it in the oven at a at the desired temperature for the 65 to 85 seconds as described, I'm taking a little more time, given the fact that I don't have a necessarily industrially consistent process. So what I've done here is I have put the Kydex in at the minimum temperature for a few minutes now. And so we're going to take a look at this and we're going to say, okay, this guy is about 230 to 240, yeah, on average, right, across the surface of the material. And obviously that's not enough to distort it or cause any kind of damage. However, what I want to do is, since it's such a small oven with a concentrated heat, I want to bring the core temperature up rather than essentially shock the surface temperature into being hot enough to mold. So what I just did is, as you saw, is I took the sheet out and I turned it around, because I've noticed in this particular oven there's a maybe even 15 to 20 degree variance in the temperature at the back of the oven and the temperature at the front of the oven. So what I'm going to do now is I'm going to bring the temperature up a little bit and wait another minute here, and then we're going to get involved with the non-contact thermometer. I just picked this up at Lowe's. It was like maybe 30 bucks or something. You probably can get it cheaper somewhere else, but it was convenient and there was stuff that I needed there at the time, and I figured I'd let the holsters pay for it at this point. So what you may discover using a more precise process is that the temperature on your oven here on the dial has basically zero relationship, other than the fact that it's a linear increase to the temperature of the material. So as you can see, I had it set at 150, but since the oven's so small and the elements have a certain proximity, the heating elements have a certain proximity to the material, I'm going to get a higher temperature than what's listed on this dial. So let's take a look at this here. Now we can open this up and take a peek. Now you see we're getting a little higher, 260. So I want to make sure that I'm warming this at a reasonably steady rate without causing any wrinkling or deformations. I'm just going to use this guy for today. I'm not going to necessarily heat it up with a heat gun because I only have so many hands. However, on the advice of a couple other subscribers, I am just putting the foam on top of the oven, and that is yielding me an average temperature of about 150 degrees, I've noticed. So that guy's just going to hang out up there, keep him warm, so we don't have a big, so the Kydex doesn't dump its heat into the foam. And we are going to hang out here. So anyway, for those of you guys who haven't checked out the technical brief section of the Kydex website, I mean, there's everything. There's painting the Kydex sheet, screen printing, bonding. There's four or five sections on bonding. There's an adhesive guide. There's repairing. There's environmental aspects, obviously, in MSDS, mechanically fastening rather, water absorption properties, removing stress whitening. There's the coefficient of thermal linear expansion. There's cutting and machining, break forming, punching and perforating, hot stamping. Antifungal and antibacterial properties of Kydex, vacuum laminating. I mean, everything. Radiation effects, UV spray. Oh, let's look at this section. Knife sheaths using Kydex thermoplastic sheet. The advantages of the Kydex sheet sheaths and holsters. Highly durable for continuous use, great color selection, easily molds the contours, can be remolded, can be cleaned with household cleaners. Possible tools for the sheath: hair dryer, foam, masking tape, a press, an adhesive, a rivet press, drill and drill bits, belt loops, pre-molded or fabricated, screws, a type of saw, sandpaper, and Scotch-Brite. Man, we got a lot of good information. But it's basically all the stuff that we're doing. Hey, and look, they even mentioned our buddies over at knifekits.com. Yeah, it's, I mean, everything on here. So what we're going to do is we're going to come back over here. We're going to examine the surface temperature of the material. And what we have here is, you can see we're getting up to 280, 280-ish. So what I'm going to do is I'm going to then remove the sheet, turn it 180 degrees in order to ensure even and consistent heating, increase the temperature, and hang out for a second. So I hope you guys all had an excellent Thanksgiving. I know I did. My family came into town, and that was pretty excellent. I had a 10-year high school reunion that I unfortunately missed because of the family being in town, but that's okay. You trade one thing for another, right? And it was pretty cool. Pretty cool indeed. So, yeah. We're going to hang out here for a minute. I don't want to have to take the time to edit this video and cut it all together and everything, so it might be a few minutes long. What was I going to talk about? Yeah, for those of you who are interested in ordering holsters, if you need or want them by Christmas, it's getting pretty close to the time where if it's going to be much later than now, that's going to be very difficult indeed. I'm thinking that by the end of the first week of December, it's going to be hard to guarantee things that get done in time for Christmas. So if you're interested in a holster, not to rush you or put any pressure on you, and I'm going to be here for a while, but if it's imperative that you get your product by Christmas, it's coming down to the wire on that. So here we go. This guy heats and cools pretty quickly, so we're going to take a look. And look at that, 301, 300-ish. So what I'm going to do is I'm going to flip it around. And obviously this loses a lot of heat out of the oven. But what it also does is it ensures that the heating process is a little more gentle. It's not as direct and aggressive because you're sort of modulating the heat. And I think that's kind of what they may be referring to in terms of cycle time on their technical briefs. And since we don't have a oven or a process whereby we can dial in a specific cycle time, we're kind of stuck with the toaster oven. However, I think given the results that we are achieving, that's not necessarily a bad thing, and I don't want to have to go buy some, I don't know, large and expensive piece of equipment to do essentially the same thing that I'm doing right now, right? Anyway, I thought about getting a thermal probe and putting it in the oven with the material, but I don't think that's going to get me better results than this guy. So as you can see, once we start getting to the higher temperatures, it starts happening a little quicker. So here we go, 326, 328. So we're going to let that go for just another second. I might flip this guy around, put it in the hotter part of the oven for a little bit longer. And here we go. We're about to rock and roll like this. So what I'm going to do is I'm going to set up the camera on the tripod over here for the time being, and we can rock and roll. I've given up using the oven mitt because it doesn't have a lot of dexterity, and the mechanics gloves are reasonably effective. So, let's see what we got here. Yep, we're still in the 300, 320-ish range, and we haven't seen an overglossing, deformation, or warping of the material yet. So I'm going to push the temperature up a little bit higher. I'm going to come over here, and at this point I'm going to start warming up my my glue gun. Just get a little warmth on it. So here we go. There we go. We're getting on to about 350. So this guy's coming out. As you can see, there's no warping or glossing or poor side effects here. I'm just gonna slam this guy in the press. I'm not really making a holster from it. I'm just using it as a demo with a piece of scrap. Oven goes off, and here we go. We're gonna clamp this down. So I finally have been thinking about building a new press. I'm not necessarily going to get a hinged press because I feel like those can be kind of a struggle in terms of the material shifting and getting a really even distribution of pressure. A subscriber, a friend of mine, range buddy, Derek, came by and we were talking about the book press. Now the book press is basically a framework with a wheel or a crank and a screw. And what it does is it applies pressure centrally to the assembly. So basically it comes up around here and then you clamp it down with a basically giant bolt in the middle. And I think that's going to be the next step, because it'll allow me to raise and lower the press vertically without any kind of lateral shifting, and it will also allow me to apply a tremendous, overwhelming amount of pressure to the mold, which is what I'm really looking for. So I think I was talking to somebody else about that. Here, let me check the email here. Yeah, I was talking to somebody else about the book press too. Somebody who lives near me, and they do some woodworking. But at any rate, yeah, I think that's going to be the next step. It is a superior press. So this guy's going to hang out here for a minute. I'm not going to bore you too much. So this should be pretty cool. I expect really good results from this. So essentially, if you were to just throw that little sheet of plastic into the oven and it's cranked up to, it might say 250 degrees on the dial, which really means that you're achieving, at least in my oven, I'm achieving a surface temperature of, in some places, almost 360 degrees. So that's a 100-degree difference over what it says on the dial, right? So that's what you get when you're not working with precision equipment. However, this is a DIY environment. It's going to, you win some, you lose some. So if you just throw it in at that high temperature, especially if it's touching something that's already hot, or if this heats up faster than the Kydex, because this is much more conductive, the tray is going to get hotter than the material. So what you could do is you can cause a situation where one face of the material, for instance, the the back face that is touching the tray heats more rapidly than the rest of it, and it contracts or expands, you know, warps in some way, and then the material overglosses or gets shiny all over. So it's clearly much better to heat it slowly. Now, I am rehashing a certain amount of what I talked about in the previous video about getting great definition every time, but I think I'm adding a lot of good information in terms of specific temperatures. So, you know, of course, if you have a large oven, you're going to have to monitor it differently. It's not going to be as direct a heat. It's probably easier to set your large oven to 350 and actually have the internal temperature be closer to 350, because, you know, it's got there's more air inside that needs to heat up, and the heating elements are further away from the material that you want to heat. In a smaller oven, it's much more focused, so you should, you know, I guess as a rule of thumb, you should anticipate that in a toaster oven, the actual internal temperature is going to be higher than what's than your dial input. So take that into account. These aren't that expensive. I mean, if you're really getting into making holsters, this is a good little, you know, this is a dollar well spent. You can probably get this at Harbor Freight for even cheaper. That would not surprise me. Whether or not it's worth a damn is really up for grabs, and I found that to be true about Harbor Freight pretty consistently. I have a 3-pound hammer that is probably the most durable, incredible, reliable piece of equipment I've ever bought, and it's saved my ass a million times, and I bought it at Harbor Freight for like $3. But there are other things that I bought at Harbor Freight that have broken the first time I've used them. Not to say that other companies aren't going to give you the same kind of reliability, but Lowe's is right around the corner from me, and I didn't have to drive, so that's a big difference. And also, you know, that 1-ton press is holding up pretty well. However, I have bought like a vise. I used a vise from Harbor Freight once, and I was replacing a tie rod end on a car, and the nut had seized, so I put it in the vise and turned it, and the nut acted like a cam, pried the jaws of the vise open, and cracked the entire vise. And it was as though, instead of the actual cast iron, they just gave me the sand cast for the vise. It was such an incredible piece of crap. And, you know, of course it happens at like 4 o'clock on a Friday afternoon, and you promise the person's car back to them. So, you know, Harbor Freight, hit or miss, we all know that. So anyway, this guy's going to open up, we're going to take a look, see the definition that we got, pat ourselves on the back, and thank Kydex for putting out all their information about their plastic sheets, etc., etc. I can't believe I'm still using this little press. I am, however, replacing the foam with relatively greater frequency. But, an additional advantage of heating your foam is that, you know, if you make a few holsters, you'll start to see that it gets like a divot in the foam. And if you heat it up, it'll relax the foam a little bit, and you'll get a more uniform surface. So, here we go. Right? And let's take a look at that. Look at the definition that you can get from 0.08 thickness Kydex at home with a non-industrial process by paying close attention to the temperature and condition of the material. And as you can see, we don't have any kind of like excessive overglossing. I mean, I've seen pictures of other folks' holsters. You know, I look around online to see what other companies are doing, and they'll have great definition, but the whole thing will be like really excessively shiny. We did pick up a little bit of shine here, and I think that's going to happen just as you get into the higher temperatures. But it's not like the overglossed, like clearly, oh, hey, the blue gun comes off a little bit, but brake clean can fix that. So, I mean, look at that kind of definition that you can get at home in your toaster oven. I mean, people are spending probably thousands of dollars on equipment, and this is a $20 toaster oven with a, you know, $30 thermometer. But at any rate, I was looking at some other holsters. Yeah, and they look like they've got pretty good construction, but it looks like they scorch the crap out of them and slam the gun in there, and, you know, they don't really get a really great, consistent surface. It looks like, you know, melted plastic, sort of. I don't know, maybe I'm being picky. I mean, look at that. You can even see, like, the rails and whatnot in there. You can see, like, the frame pins. I mean, these little marks. Focus, please. Come on, jerk. Focus on my... These little divots here are barely even visible on the gun, and they're coming up in the Kydex. You know, you can read all the text, the model, the make. You can even see where it says XD. You can barely even see that on the pistol. You know, so stick with it. Slowly heat the material evenly, consistently, and over a reasonable period of time until it gets to about 330 to 350, and then put it in the press. Obviously, the .06 thickness is going to become more pliable at a slightly lower temperature, and you also don't have to heat it as long because you don't have to. You're not. There's not as much. You know, the core of the material isn't as substantial. So you heat the core faster and it becomes workable a little quicker. So you can probably start pressing the .06 a little closer to 310 degrees, 320 degrees after a shorter period of time. Now, none of this is sort of a set it and forget it kind of thing. You are going to have to, you know, monitor it and check it and, you know, keep an eye on it. You can't just, you know, put it in the oven and go make a snack, for instance, because that's going to lead to a situation where you've overglossed or melted it. But this does give you a better guideline than, you know, what does it really feel like or look like, or, you know, is it melting or shrinking? Because sometimes, you know, you're really dancing on the edge, you know, between getting it hot enough and destroying it. Now, with a consistent methodology for temping and inspecting the material, obviously you're going to get more reliable results and not be always on that frantic edge of, oh my god, I gotta press it now before it melts. So good luck, guys. Hope you use this information to your advantage and make some excellent holsters, and have, you know, hope you had a great Thanksgiving.